Hello there! Welcome to another Cynthium Live Hack. This week we are doing some more Rock'em Sock'em robots. Tonight's beverage of choice, water. The drink of champions. Because we are the champions. Maybe I'll have to play that song this tonight sometime, because I think every live hack except for a couple for the Rock'em Sock'em robots, I tried to have like some sort of like song title or something like that. So it's always fun to add something silly like that. Anyway, I added a new scene for us today. So as you can see, this is the schematic for the CNC shield that we're using. I'm just kind of trying to map out and see how many pins we have, what we can do for moving servos, and also the limit switches and where they could go. I have a few ideas, but we'll see how it goes. Let me just pop up, see if this is going live. Yeah, there we go. Just need to unmute that. Okay. Picture in picture. So we'll go back. Hello, Nomad. Thanks for joining us. Oh, wow. This is picture in picture in picture. It keeps on going down and down. Pretty neat. Anyway. Shut this down. We will need to go to getting started, and we will need some Arduino code. We go to the Uno. Oh, that's Leonardo, my bad. Go with the Uno. And we have DJ's centered firmware source code, and then we also have the tutorial. Open that in a new tab, we'll download that. Oh, that was quick. I think we'll just put that on the desktop for now, I guess. Looks like I've downloaded it before. So, extract to the desktop. Why not? Oh, it's probably on the other desktop. There we go. So I think it looks like we need these two libraries to be, the header file and this source file to be included in its folder. Let's open that up. Take me a quick second here. Okay, here we go. Looks like it's included since it's in its folder. Oh wow, there's quite a bit there. So I'm wondering if we can still keep the source code on there, or the stepper movement code on the Arduino itself with the code for allowing it to be an EZB. Not too sure how that's going to work, but we'll definitely do some testing here, and we'll try to control some servos from Easy Builder. See how that goes. I created this guy here to handle the power management for the servos. So we have a 12 volt supply that we're using right now. 12 volts, 1.5 amps. That's powering our entire CNC board. So we're gonna kind of bring that down, lower that voltage so the servos can use it, lower it down to like 7 or 6 volts. We have micro servos on here so they can handle it. And then these wires will go to the Arduino, and that will control those servos. So we got power and signal here for the servos. Yeah, so what I'll do, I guess I'll overwrite our CNC code with this code, and then see if we can hook it up to Easy Builder. Okay. Tools, Uno, COM4, perfect. Let's upload. Just compiling still. Uploading. Done uploading. Successful, great. Okay, I'm going to load up Easy Builder here. Alright, we'll move this over here. And we'll see if we can connect. So in the drop down, COM4 should show up. Hit connect. Could not connect. Well, let's try unplugging and plugging it back in. See if it just needs a reset after you upload that firmware. I have a suspicion I know what it is, but let's try that again. Okay, cannot connect. So let's see what our settings are at for 9600 baud. Well, I don't know what we're at on the Arduino side. Let's have a quick look here. So I know that we have all of our baud rates here, and 115/200 is the maximum. See, let's search baud rates and see what it's set to. Baud. So let's search for baud. See where that's defined. Oh, there we go. Boom. Okay. So let's switch that in Easy Builder. Don't need that anymore. To 57,600. Save that and try connecting again. Oh. So see if that's saved. On EasyB0, 56,700. What else could I be missing? I can try rebooting one more time. There we go. That was it. Just needed to reboot. We're connected. Alright, so let's add some stuff. We're going to go to servo, horizontal servo, port. Let's just try D9. Change the max minimum values here. Oh yeah, I can also right click and just do it the easy way. Save that. And then, oh yes, one thing I forgot. I need to add a way to plug this into the 12 volts. So I'm gonna have to figure out a way. Let's go back to our diagram here and see if there's anything on the, okay, let's go see if there's any way to plug into the V in port, external V. This is what we're looking at. Do you guys see external V anywhere? Hey Will, welcome. External V right here on pin 8. Is it broken out at any other pins? So if you're just arriving, this is the schematic for the CNC shield that I have for the Arduino. This kind of shows how all the pins are broken out. We're kind of looking for places where we can have the servo plugged in. So on the Easy Builder side, I'm going to be using this D9, the digital 9 port. See if that works with our servo. But I need a place to grab external voltage from. And it looks like I can grab it. If I don't want to grab it from here, I can grab it from pin 8 of these motor drivers. Let's see. Yeah, it's going to be tricky to try to get some wires into this connector right here is a terminal connector, that's what they call it, where you have, you know, two little screws you can adjust and stick the wires into the terminal, and then you screw them back, screw the connections down. But it's all hot glued into place down here, so it's a little bit tricky. Very tricky business. So I could just solder onto pin number 8 of these motor drivers. But that's a thing though, I don't really have a good reference of what pin 8 is. I don't know where they start with pin 1 on these boards, and that's the frustrating part. So yeah, maybe we'll just release some hot glue, put some wires in, and yeah, make it happen. Let's do it. Sometimes I don't know. You think that you might be able to find a way to not have to remove some stuff, but sometimes you just gotta buck up and just do it. And just hot glue it back in place after. It's fine. Okay, so I'm kind of disconnected from Easy Builder there. Alright. I'm going to switch camera views so you can kind of see what we're doing here. Alright. So, here is our Arduino board that I hot glued in place. I sprayed some alcohol back here to release the hot glue. So let's make it happen. Actually, I could just release the hot glue on this barrel jack and then remove that. That would probably just work. There we go. I guess I could reuse some of that hot glue, but I'm a bit lazy. I won't do it. So, actually what we could do is just cut off the end of this guy and put the wires into there and put this guy back. I think that would work. Let's do it. I'll leave a little bit on there so I can reuse that end at some other time. Okay. Get those in place. Ugh. Should twist these wires first because sometimes they get frayed and some of the fibers of the wire go and touch the other side, and that's not good. You don't want any shorts. Shorts as in short circuit. Not as in the small pants that I'm wearing right now. Alright, that ground connection is just not wanting to go in there. We're gonna have to use the needle nose pliers. There we go. Get our barrel jack in there. There we go. Try to line up our barrel jack as best we can. Now we gotta find a home for this guy too, somewhere in here. I think I have a spot in mind. Alright. Thinking just down in this area. Kind of sneaking under all the wires. So if you're just joining us and you didn't see what I showed at the beginning, this is a power supply that's going to power all of our servos. We can't give the servos the voltage input that we have here because that's 12 volts, a little too much for those servos. So we got to step the voltage down with this guy, and that's what I created here. So we'll hot glue that down, hot glue our connector back in place. And we'll be on our way. So this is part 7 of this hack. It's officially become my longest running hack. So, yeah, definitely was not expecting it to be this long. So many challenges to overcome with this hack. And that's the way it goes sometimes. Oh, we need some more hot glue. We'll get this positioned in place right away here. Wait for that to cool down a little bit. Okay, oh, not good yet. I thought that was good enough, but it's still not cooled down yet. I'll just stick this right in there. Just make sure it's positioned in the right place. So we'll have to trim this down. So it's around 7 volts. Right now it's at 8.5 volts output. I think this is a 3 amp supply, so we should have plenty for the servos. I'll just go down to 6.5. They don't need that much voltage. There we go. So I'm not really happy with how this is fitting. I think I'm gonna have to really reef on that while I hot glue it down with some more hot glue. Okay. Okay, that'll be good there, but I'm gonna have to wait here for at least a minute holding this thing together so it'll cool in the right place. So what's everyone got on the go these days? What projects are you guys working on? I've been so distracted with this project that I haven't really kept a note on whatever other people are working on. I guess the summer is almost over and robot building season is almost beginning. Always consider the winter time probably prime robot building time, at least in Canada, because it's nice and cold outside during the winter, so it's not always pleasant to spend your evenings outside, so I'd rather be robot building in the wintertime. We'll give it a little longer. So I did secure down the switches, or sorry, not the switches, the infrared sensors for the heads. Secured those down this week. I also put some reflected tape underneath the, I guess, the head where the sensor bounces off of. That'll give us like a stronger signal. I did do some testing as well, and got a change in value on those two sensors, so that was good. I have them working on A0 and A1 on the Arduino. We'll probably try to read those as well in Easy Builder and see how they come up. I was having some issues with them changing values. I'm not too sure what that was all about, but so let's say like it showed up as 400 when the head was fully down. Well, after a few movements of the head moving up and down, it would change to like 600 when the head was fully down. So I'm not too sure what's up with that. There's some drifting values. I'll have to figure that out. Okay, I held that long enough, so it should be good. Oh man. seems like this doesn't want to plug in perfectly, which is annoying. Well, you can see that the plug is like at a weird angle. And it's not like plugging in perfectly. Oh, whoops. Didn't mean to slam the robots. Just a very off-centered connection now, which is a bit annoying. Oh, that's what happens when you adjust things, I guess. Kind of knew it would. I see what happened. It also came unhot glued from there. What I should do is just, we'll take this hot glue off. I'll do a bit of sanding here to rough up the plastic, and then it hopefully should hold much better. I think there's also a gap, which is playing a part in it not connecting all the way down, because it needs a certain amount of length. So yeah, let's just fix that. We're here. Why not? Let's do it. Peel that hot glue off. Go. Oh, it looks like I deformed the connector when the hot glue was hot. Maybe that's why it's not connecting so good anymore. Let's pull it out for a sec, see if I can fix it, or else I can replace it with another one. Yeah, that's the exact reason why it was messed up. Here, I'll show you with the close-up cam. You can kind of see that dent in there. Yep, that was me. I messed it up. Oh ho ho. Do you spend most of the winter outside, Will, or inside building projects? And do you get a lot of snow where you live? Because we get a bit. You know what, I'll heat it up and pry this plastic back. We'll switch views here to my workbench. Here we go. Yeah, I do a lot of indoor stuff. It gets cold here in the wintertime. Sometimes, I think this past winter we had almost a whole month that was close to minus 20, minus 30 the whole time. That's Celsius, I guess. How about you, nomads? Does it get pretty cold where you're at? Well, that was kind of easy. As soon as I heated it up, it ended up just flexing outward. I never really thought of about how thin the walls of these barrel jacks are. You can easily melt them, I guess. Yeah, that's a way better connection now. Okay. We have to do some weird, weird impromptu hacks as we're hacking this other stuff. I guess that's the way it goes. Okay. Screw these terminals back down. Bend this. Oh, I know what I should have done. Yeah, okay. Let's take this back off for a quick sec and do some sanding, because the hot glue wasn't really sticking to the plastic there. I don't know how I got it to stick last time, but this time it wasn't. So I looked into like a new microphone, something that'll pick up my voice a bit better. And I realized that if I get a lapel mic, you guys probably won't be able to hear the music. And I tried a different mic, a USB mic that I had, and it was much lower, unfortunately. So the search continues. I might get a wireless lapel mic, but I'll have to like make sure the music source is probably like a little, or the music speakers are a little closer to the microphone. Tonight we're playing Spotify again because Spotify was awesome last week. So Spotify, the playlist is called Copyright Free Music Catalog. So if you're interested in that, definitely check it out. It seems I still get at least one copyright infringement email from YouTube letting me know that there was something on the playlist that I didn't like, but I think it's mostly like ads these days. It's just like someone has a song on an ad that they paid for, and then it picks that up. Actually, I'll get some air cans to clean this dust away. There we go. Okay, let's put it all back together. Oh, what's this? A gas explosion? Holy! That's insane. Wow. I hope your house was okay, Nomad. And it's very sad that someone passed away due to that gas explosion. Man. You never know when that kind of thing could happen, hey? Like just a fault in your furnace, and it's kind of crazy to think about. Okay, gotta get this black wire back in there. Plug the barrel jack back in. There we go. Tighten these screws down, and then hot glue everything together. One step forward, two steps back. That's the way it goes sometimes, but hopefully it's two steps forward and one step back. That way you're making progress. Okay, I'll try to bend this into the right spot. And then I won't have to hold it. With the additions of these wires here, it is making it a little bit tricky to get this back into where it needs to be. But I think Here, let me test the fit for a second here. Yeah, I think if it's a bit off, we'll be fine. But yeah, it's fitting way better than it was. Okay. I think that'll be fine. Yeah. Close enough. Let's hot glue that bad boy in. So Nomad, did they find the source of the explosion? Was it a fault in the furnace or something to that effect, or did someone light a cigarette close to a gas line or anything? Just wait for that to cool down. Once it's cool enough, we will hook up the servos. I think what might be easiest for this hack is just translating our Arduino code to easy builder code, but we'll have to see. We'll have to check. Easy script, I should say. I just can't remember if easy script can go down to microseconds. I don't remember. We may not have to actually, so we'll see. Still not cool yet. Might as well plug one of these guys in while we're waiting. Plug this into...
Nope, not that one.
Let's look at our diagram here.
That's better. Play on demand with Premium. Get the right song for the right moment with Spotify Premium.
So we want 9, so that's X end stop. And I don't know if that's X end stop plus or minus. What I can do is use my multimeter, check which one is D9 here, and then test. Oh yeah, I forgot to turn this off. Whoops. Okay. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. See if it's X plus or X minus. Yeah, it's X plus, it looks like. X plus and X minus. Interesting, those are shorted together. Excuse me. That means like either limit switch gets hit and I guess it shuts things down. Okay, so plug that into X. It looks like this is pretty solid. Maybe give it a few more seconds. While I'm here, might as well plug in the other servos. Oh, these are not servos, these are limit switches. Gotta make note of that. But this is a servo over here. See what D10 is Y end stop. So I'll unplug these limit switches here. Okay, let's do some testing here. Sorry you couldn't see what I was doing there. I apologize. Oh yes, I guess you found that. That answer to your question, I guess, there, RoboRed. Or actually, maybe, no, it was somebody else that asked that question. I think it was Easy Ang, I think. Never mind, my bad. Yeah, the company called National Robotics Inc. here in Calgary purchased Easy Robot earlier this year. Okay, that fits in there super snug. Okay, we have a couple servos hooked up. Kind of scared to let these connections just be fancy free and not connected to anything because they could short out on something. So let's connect them up. Black to black. Okay, perfect. There we go. Now, here's the test. We are connected to the Arduino. If I think RoboRad, you had the question about connecting up your Arduino or your Latte Panda, I think the Arduino side of the Latte Panda, to Easy Builder. And I think besides that setting that DJ talked about, where it's like the DTR setting, you do have to have the right baud rate. Just be aware of that. And the default firmware that DJ supplied is at 57600 for the baud rate. And I also had to like reset it in order to connect, so be aware of that. Okay, let's see if I hit center, if oh yeah, I heard a servo move. There we go. Can you guys see that? The red, wait, am I, yes, okay. The red guy's arm is moving. Perfect. That's excellent. Put it back to 90 degrees. So that means we should be able to, oh yeah, do another servo. So we'll add another horizontal servo. Change that to 1. Change this to 180. Port, I believe it was 10 that I actually hooked up to. Oh, there we go. So that servo position is a little different than the other one. So we'll make a note of that. So we do have a punching arm for the red and the blue at the moment. So we have that. This is working out well. Now let's add some ADC. Let's do we want meter? Yeah, sure. No, I don't want meter. Let's add ADC value. Okay, set this up for ADC 0. Perfect. We'll add another one. We'll set it up for ADC 1. see how this works. This one changed. Went from 2.15 volts to a little bit lower. See, this is what I was kind of mentioning to you guys earlier. The value when it's clicked into place changes a little bit. So now it's at 2.3, popped up, 2.1 volts. Seems to drift a bit, and I'm not too sure why. See, it went up to 2.4. So I need to figure that out, what's going on there. We'll try the other side, the blue side. Oh, there we go. I was just telling the guys earlier that I put some reflective tape under the heads. I'll see if I can show it to you guys. Oh man, this could be tricky. Right there. I don't know if you can see that. It's pretty difficult. Terrible angle. But right under there, put some reflective tape there so that the sensor could see the head a little better, just get a better reading. See, the blue one seems to be doing good. 2.4, 1 point, well, I guess that's drifting a little bit too. 2.4, 1.7. I guess, yeah, that one seems to be working. It's just that red one is just a little weird. I might have to check if, yeah, there's a solder joint broken somewhere. We'll have to do some troubleshooting with this red dude. Probably won't do it tonight, but at some point. So even that drifts a tiny bit. And it could just be like the sensor is reflecting a little bit better at times. But this seems pretty stable, around the 2.4 range. Or if you're going by like a, the ratio value, we're going up to about 170, 180, and then down to 150. Now it's changed. So we'll have to do a little bit of troubleshooting there. Our servos are working, our punching arms. There we go. And so we're going to have to look at our CNC code, which, okay, we'll flip over to Easy Builder here. Actually, I wonder if I can position this camera so you guys can see both what's happening here and what's happening on screen, or I can just do, not that, this, yes. Just increase the size of that. There we go. You don't see me, but you see the rest of what's going on here. Okay, so let's go into Cynthium, add a script. Easy script here. I don't know why it keeps on popping up on my other screen. Oh well. We will go easy script. And what do we want to do here? We want to look at the sleep function. So sleep is in milliseconds. Maybe I'll look, see if I can search microseconds. Doesn't look like it. Only Micro is Microsoft. So I don't know. I think we can only do millisecond timing, which may be okay because here I'll pop up our CNC code here. Let's see what the timing is like, because I think, yeah, so I'm delaying microseconds 2000, which really that's 2 milliseconds. So we can use just milliseconds if we wanted to. I think that will probably work. So yeah, this is our sensors that I was doing some work with recently. So basically these functions here are just reusing this function for the timing. That kind of gives us the amount of steps. Just like a high-low for 2000 high-lows. Going through this here with the, well, I guess it's 4000 high-lows because it's 2000 here, 2000 here. So that's, yeah, 4000 microseconds to do this loop. It's kind of pulsing the direction pin. So yeah, I'm not that great at coding, so I can't really explain this, what the function is doing that well. I don't know exactly how it's returning all the values and stuff and what it's taking in. It looks like if you set up the steps here, I think this value is setting up the steps. Yeah, right here. So I'm saying 100 of these pulses, 100 steps, I guess. I don't know. Yeah, I'm not really great at explaining this kind of thing. Sorry, guys. But we'll see if we can replicate it in an Easy Builder. So we're going to port this Arduino code into Easy Builder and see if we can move the stepper motors. I don't think I'm going to use all the same like functions and stuff. We will make one function that we'll call. Can I? I've never really actually used a function myself, like made my own function in Easy Builder. Can you? So all the functions are given to you already. I hadn't really thought of like trying to make my own and seeing if it's possible. What I could do is make a script and then call that script. So this whole thing could be one function, basically. Call this script from another script, and that would likely work. We'll see how it goes. I'm probably going to be messed up because I have Arduino code on one side and EasyB code on the other. So to call or to make a variable, you need to have this $sign in there. So we'll make a value, and then we'll make a I think it's a for loop, I'm pretty sure. Yeah, for loop. Same thing could be had in. So let's go for loop. If I search for for, I'm just going to get a ton of stuff, so I'm just going to scroll down here. If, else, repeat, get. I don't know if we do have a for loop or if we just have to use wait. Wait for speech. Sorry guys, yeah, I'm kind of out of my element in terms of programming. I don't do this very often, but yeah, do my best. We can definitely wait for stuff, and we can do if conditions. Wait until a certain time to do something. We can do like, we can do a go to. Oh, nice. I didn't know they can use a return as well. Repeat. That's what we want. I forgot. So repeat is like our for loop. So repeat. And let's just do X. Zero to 100 and increment by 1. And then end repeat. So we're gonna have to put something in here. We'll go digital write high, delay 2 microseconds. Or sleep 2 microseconds, I should say. So it'll be set. I believe the stepper motors are from like D2 to D. Let me see this diagram. Okay. They're all here. So D2 to D4. So D2, I think if I go to set digital, set servo, set digital. Oh, it's on or off, true or false. Okay. So we'll just go on. Sleep for 2 milliseconds. Set D2 off. I wonder if I have to use lowercase. Not too sure. Okay. Let's just, we don't really need this at the moment, so we can comment that out. Let's see if this does anything. I think we also have to set the direction, which I didn't do. So and I think this has to be in a loop as well. Oh yes, I think you have to pulse the direction pin while you're pulsing the step. no, wait, sorry, you have to do this to the direction pin, and you have to do another loop. So we will use this over again. I wonder if I can tab this over. Yeah. So if we were using oh yeah, that's the step pin. We're going to switch these around, I guess. So step is 2 and direction is 5. So let's change this. How many times were we looping over here? We had a full delay between it. So it looks like this will have to be repeated, or sorry, copied and pasted. And then there is a second delay, so let's go sleep. 1000. Between each. And this will be set D2. D2 to on. So I think this is, oh yeah, this is moving it back and forth. That's what's happening here. So the direction, oh, okay, I think I got these mixed up again. Because these, we want to be the step. Okay, that's fine, D2. Oh wait, no. This is D5, this is D2, and D2. I'll just stick a space between these. Oh, between these, just to make it a little easier to see what's going on here. And how many times do we want to loop? We can loop indefinitely. So, or loop 100 times, whatever. This can be Y, just so we're not mixing things up. So we have to reset our values. Okay, well, let's see if that moves anything. I don't hear anything moving. So, let's see here. X step is 2, X direction is 5. That's right. Alright, I'll just try running it again. Let's see if there's any. Nope, that's not working. Oh, I did forget this. coding skills are really showing. Okay, let's run that again. See if any of these axes are actually locked or trying to move at all. The red guy's not trying to move. Seems the blue guy's trying to move. Doesn't seem like it. Well, maybe. No, not really. So that doesn't seem to be working. I think maybe, aha! I know what it is. So if you look at the Arduino code, there is a pin that is called the enable pin. Pin 8, yes. So let's start with that. Set D8 on. Okay, let's see if that works. Nope, not yet. No response yet. And I wonder if it matters if I have these capitalized or not. Okay, save that. Let's add digital, set digital. Oh, it's on D8 already. Oh. I did hear something happen when I enabled D8. Maybe D8 has to be disabled for it to work. Off. Yeah, there we go. What the heck? Oh man, that's very weird. Okay, that was our issue. It was the enable line, and it has to be tied low. I should have read the code. Okay, let's... Yes. It's working with Easy Builder. Sweet. So we know what to do. Excellent, excellent. Yes, remove that. Right on. So we have stepper motors working. We have our servos working. We have our sensors. We need limit switches. That's what we also need. Okay. So we gotta fund. I think we will have to use the ADC to read the limit switches. I think. So let's add some more ADC. We'll make this ADC 3. Actually, ADC 2. Oh yeah, I guess I'll have to change the numbers here. 1. This will be 2. All right. 4. 5. And that'll be it. I think I... Did I miss 3? Oh, I think somehow I missed 4, my bad. Oh man. Okay, there we go. 4. And then we need one more, 5. Okay. So let's take a quick look at our schematic here. I think I'm gonna have to release everything because I can still hear. Whoa, that's not good. Once I released everything, I could hear, I can smell actually the stepper motor warming up too much. So it's just holding a position. So let's try that again. Oh, that's interesting. Why is everything moving? Oh, I know why. We're still doing some stuff with Easy Builder here. So our script is not working at the moment. Good. Connect. We're connected. Good. Oh, we're not connected. We're connected now. Whoops. There we go. That's what I was looking for. There we go. Okay. So what I think I will need to add file. Oops. Project add set digital 8. So if I turn this on, it will disable the steppers. That's our enable pin. So that'll be handy to use. Limit switches, that's what we want to do now. So we want to attach those to some of the analog pins. We'll move over here. We're going to probably connect the limit switches up to ADC 2, 3, 4, 5. That's the plan. To find these pins, that might be a tricky scenario. 4 and 5 I have found, but the rest of them, coolant, I don't think I know where that is. We will have a look to see if we can find them. There's this big long header just down at the bottom of the shield that has white and black pins, and that's where the limit switches should hook up to. So we have resume, e-stop. Those are not labeled in the diagram, I don't believe. But we will see if they're connected to some of the ADC pins. Okay. Found cool enable, spindle, spin enable, and spin direction. No idea. We'll try the cool enable. Get on there. Okay, there we go. And we have one more limit switch. Here it is. Okay, let's connect that all up. Okay, so I'm just going to hold it like that for a sec. We'll jump back into Easy Builder, and you guys tell me, or maybe I'll see it. I don't know, my microphone's in the way. If any of these drop down to 0 once the limit switch is activated. There we go. ADC3 is this limit switch over here. So that was the cool enable pin. Beauty. Okay. Good deal. Try this limit switch down here. Nope, it doesn't look like it's connected to any of the ADC. Try this limit switch up here. Nope. Nothing, but something got timed out. That was weird. No. Oh, darn. I wonder if it's because I'm hitting that limit switch and it's on like the wrong, it's probably on the wrong port. We'll try this again. I'll try clicking the other limit switch and see. Maybe it's, I'm guessing that I probably connected them up to the RX and TX lines, I'm guessing. So that's what's transmitting, which is D0, D1 on the Arduino. And that's what's transmitting to our computer via USB. So if I'm shorting those out, it's definitely like messing with the communication. Okay, let's try this limit switch down here. See if I can get to it. Oh. I'm gonna have to use a screwdriver to activate that guy. Oh, ADC2, there we go. Perfect. Okay, we have ADC2 and ADC3 found out. So that's that guy. Oh wait, I don't know which is which here. Oh, actually, there we go. I know. Okay, let's try some more pins here. Let's try spin enable. Okay. Anything change? Go to 0. No, nothing. So that's not it. And the rest are the end stops. Oh yes, I forgot. We do have 2 more ADC broken out up here. Yeah, look, this is ADC5 that I'm touching, it's going all crazy. And ADC4. Yeah, it should be going crazy as well. So, I think we found them all actually, my bad. So, disconnect these. Actually leave one side connected to ground. Ugh. Such a mess of wires in here. Okay. Put that back on. Okay. And then stick one of these on the ground line. One of these on, let's put it on ADC4. Check if this is still working. Yep, ADC3 is still working. See, ADC2 is working. Perfect. And now let's check if guy's working down here. And that should be ADC4. Yeah, ADC4 is working. And I just need to break out pins off of this guy. And that'll be ADC5 for our final limit switch. So I just need to grab a couple of breakout pins. And then we do have to find two more pins for two more servos. One of them is going to be easy to find, and the other one might be tricky to find. I only seem to have 3 open pins, so we'll see how that goes. Okay, we need a male to female connector. There we go, got one. Where's our limit switch at? Here it is. So this will go to ADC5, which on this board is labeled as SCL on this little blue and yellow header at the bottom, and then the other side goes to ground. Okay, let's try that out. ADC5. Yeah, there we go. Beauty. So we know that our limit switches can tell us when we're bottomed out or homed in the home position of each axis now. We will have to test out all the other steppers, make scripts for them and that kind of thing. But for the time being, let's figure out our servos. So if I go back to this diagram here, so we actually took these 3 lines which were connected to the end stops, and we left them open. We're actually using them for servos. 9 and 10. 11 will have to be used for a servo, and then we have one more pin to find. So all these are being used up from 2 to 7 for all the stepper motor drivers, as well as 12 and 13 are also being used. So yeah, this I think we're using every single pin. Dang. Because we're using these 4 for limit switches, these 2 for the head sensors, all those are used up for the steppers. The enable line is pin 8. What we could do, we could use pin 8 as for our servo and just keep these always enabled. I would have to do a physical hack, I think. I'd have to remove the trace. Cut the trace right here. Yeah. Cut the trace and then just make these always enabled, which is not ideal because it can't shut down my steppers once they're active, which heats up the stepper motors if they're holding a position for a while. That's the only thing I can think of. We could just have it so that both the fists punch at the same time, Or we could have it, one of the robots just uses one arm to punch. But that's not fun. I think I think we will have to hack it. We're gonna need our pin 8, and then we'll always enable the stepper drivers. Or maybe I'll just have like a switch. I'll put a switch on the side, kind of enable the motors, or a switch under here or something, like a little toggle switch. And that'll turn on and off the stepper drivers. And so I think that might be good, because it's always nice to have like a kind of like an emergency stop sort of thing. It'll be my emergency stop button, basically. Shut down the steppers. And then we'll use pin 8 to drive the last servo. So here's the thing. Everything is hot glued in place. Everything is connected up to this shield. In order for me to cut the trace that goes to pin 8, I have to get the shield off the Arduino. Such is life. Like I said, 2 steps forward, 1 step back. That's the way we roll around here, I guess. That's the way it goes. We want that last pin, we're going to have to work for it. Dang. Man. What a pain. Well, at least everything is connected to the enable pin here. So we can... Actually, we can just put a... No, that's where... Yeah, we'll put our switch across here. And once the switch is switched... Sorry if you guys can't see how these pins down here, but it's this header. No, I don't know if it's on this diagram actually. There's a header that has blue and white pins near the top of the CNC board, and it has the enable broken out. It doesn't actually, yeah, I don't think it even shows it on this diagram. But it is broken out. I'm sure all the stepper drivers are all connected to this pin. So once I cut it there, I am going to have to run a wire out for the servo connection. Just looking if there is actually that trace that goes to the enable is actually running right there or not. It actually might be. I'm gonna have a quick look with my good old flashlight. No, unfortunately that trace is going from pin D2 and coming all the way up. If only it could be that easy. So what I'm gonna do here is kind of label some of these, some of our limit switches, because man, they're all over the place. And our sensors as well. Or I'll take a picture or something and then unplug everything, take that shield off, cut a trace, solder a wire, put it back together. If it's not one thing, it's the other. So good times had by all. Let's make this happen. Time to unplug almost everything. Oh man. What I might do, which might be easier than like trying to label things with a marker or something, is we'll just use our trusty brother labeler. These guys are pretty handy. So this one is on SCL. You just add a bunch of spaces, then you write your label. I could actually make it into. Oh, whoops! Hit that twice by accident. You gotta make the text a lot smaller. Actually, just go function size small or large. That's all we got. So I'll just make the next one. SDA will be in the small printed format. This will just make it easier whenever if I ever have any wires disconnected, you know exactly where they go. We can now power this stuff down. Might as well save what we got going on in Easy Builder here. Save as Rock'em Sock'em. Oh wow, I already have a test file, so let's call this Rock'em Sock'em 2, the sequel. Okay, cut that off. Let's say printing it small saves us so much tape, so let's do it that way. Yeah, we can disconnect. Plug the power. USB we can unplug. So this will be SDA. Switch here. I might move some of these limit switches because but for now, just label them. That one's resume. I'll just call it RES. There's hold and abort. Yeah, there's not going to be much action for a little while, guys. If you need to, grab a drink, take a break. It's just going to be me labeling a few things here and then taking that shield off. Then the real action will be me soldering some stuff, I guess. Cutting some traces, soldering some stuff on. I'll have to make sure that once I cut the trace, it's still not connected somewhere else, so to make sure that gets cut correctly. I wonder if my hot glue worked down here. Oh, of course, nope, didn't. Okay, we'll disconnect some of these limit switches for now, since we have them labeled. So these brown wires are the servo grounds. And then the servos we know are broken out of those pins. X, Y, and Z. guess I could have labeled them. My bad. We'll figure it out after. This one is cool. Okay. Yeah, while we're here, I think it's the classic. It doesn't stick to smooth plastic, so I'll rough that up. Use some more hot glue that guy down. Once this guy is out of here, I should put some markings actually. Let me know where the end of this guy is. Well, the Arduino will still be there. Never mind. I'm just taking the shield off. What am I thinking? And these don't matter which one is which. I did find some 4-pin DuPont connectors, so that's perfect. So now they're all together in one connector. It was really painful when they're all separately, when you're trying to plug it in and 4 different connections are going like all over the place when you're trying to poke it in. So annoying. Okay, I should label that one actually. It's an important one. 5 volts. Okay, we have almost everything labeled. Well, all the labels I want to label are on there now. Okay, now it's time to release the shield. Get our trusty spray bottle. Where are you at, spray bottle? Turn this off for now. I'm guessing it's just like under here somewhere. Oh, here it is. Behind my water. Okay. After all that hard work of hot gluing all that, now we have to undo it all. More alcohol. Sound like a pirate or something. More alcohol, Captain. Pour on the alcohol. Oh man. Got a lot of hot glue on there. Okay, hot glue is released. Now, we have to undo this guy, so pull those 2 wires out of there. Yeah, I might as well take that out too, I guess. Okay, now the shield should come off. Yeah, beauty. Okay, let's switch our view over to the workbench. And here, let's make it the larger view. And then you can see my face again. Hello. You guys miss me? Probably not, because you can hear my voice. Alright, let's do some trace cutting. Got our trusty box cutter. Find out which one is pin 8. So yeah, the Arduino starts with D0 here to D7, I believe. 0, 1, 2, 3, 4, 5, 6, 7, yep. So this guy's D8 over on the, well, let's see if I can point this out with this camera here. And so let's see if the trace, darn, you know what? I think the trace is on the top. I didn't have to do the take it all the way off. No! Oh, if only I had looked a little closer. That's the way it goes, I guess. It was hard because it's just stuck in there. All these wires are distracting you. And you don't see that, yeah, you could just use a little knife and cut the trace just right there. Oh yeah, well we're here, we're gonna have to make a little switch. Usually doesn't take this long to cut a trace, but I want to really make sure that it's not connected. Okay, let's get our multimeter out. Okay, check our diagram. Enable is on pin 9 of all these. Ugh. I think this is pin 9. If so, they should all be. Yeah. Okay, let's see. Not connected to pin 8 any longer. Connected to enable over here? Yes, it is. So our switch is here. Now I can show you guys. Our switch is going to go onto this blue header here, right by the reset pin. Sorry, it's kind of backwards for me here. So one's labeled enable, and that's where our switch will be, our kill switch. So on is that pin driven low, and off is just, it can be open, that's fine. As long as it's not low. I think it's probably tied high, I'm guessing, with a resistor somewhere. Okay, I need to find our e-stop switch. Let's see, what do I have for switches? I think I have a decent switch kicking around over here. Got switches in my britches. There we go. It'd be nice if it was like one of those computer on-off switches. I like those ones where you push it, it stays on. You push it again, it comes off. Oh, I know where you can get those actually. Old H fridges. Yes. yes, I have some old H bridges that I could steal the switches off. Let's do it. Yeah, why compromise when you can just get the thing you want? So I was going to use a switch like this as a rocker switch, but it doesn't really make sense for like a panic stop. So we're going to use a switch from an H bridge, this guy. You press it down. Well, I guess it depends which connections you solder up. You press it down, it could go on, and you press it again, it comes up, goes off. So maybe we'll make that accessible on the outside somewhere over here, so we don't have to like flip it over and oh, know what we can do? We could have it come out one of here, one of these open spaces, and just be hanging out. Or we could just build it in over here somewhere, which I think I like the idea better. Putting it over, we'll just drill a little hole. Just drill probably a circular hole. Nothing special. Something just enough for the wires to fit through. And then we'll hot glue this switch on the outside. And yeah, we'll just hit it if we want to disable the steppers. And then, can't forget, we do need to have one male connection poking out here, one, I think it has to be male. Yeah, it does. So we'll just get a jumper wire and solder it on to pin 8. There we go. Salvage this switch off the old H bridge, solder wire. Let's just do the wire first. Where's my safety glasses? I'm always misplacing stuff. I should probably put things back where I usually normally have them. That'll make things much easier. Oh, there we go, found him. Okay. Smash my flashlight by accident here. Tin that wire, trim it, solder it onto here. Probably hot glue it too so it doesn't break off. Oh man. Whoops, I almost bridged that connection to positive voltage probably. No, ground. That would not have been good. There we go. Let's just make sure that it's not grounded or anything. So we can get ground from here. No, we are not grounded. And are we touched the enable? No, we are not. Okay, good. Oh wait, let's just check. Yes, okay, it's still working. Good stuff. Put a dab of hot glue on that guy. So I'm pretty happy that we have been able to use this board completely, use up every single pin, and we haven't had to modify it at all until now. We did have to add these two jumpers here for enabling It's easier for me to use like a pen or something. Add these jumpers here to enable D12 and D13 to be used for the A axis, the fourth axis, to be able to drive it. So do note that if you're doing a similar project, if you want that fourth axis, use these two, and then in your code use D12 and D13. Okay, next let's salvage the switch. So what we want to do is pour on a whole bunch of solder across all the pins on one side. Same for the other side. If you get enough solder on there, you can probably do all 6 pins at the same time, heat them all up. But it does have like a little bit of a lip on the switch, so I can pull on it while I solder, and it hopefully will pop out. There we go. Excellent. Okay, all we need is 2 wires attached to this guy. It's kind of a pain to hold that, so I'm just going to use the third hand. So let's see if this is open or closed. So this is normally, which way do I have the switch? I have it in the open position, so if I push it down, these 2 pins should be shorted now. And I think it's mirrored on the other side. It's the same thing on the other side. Yep, these 2 pins are shorted and these 2 are open. So we want 2 wires here, one here, one here. I'm sorry if you can't see that, it is rather small. So we will get a couple of jumper wires, female. See if I can find a black one. Black and a red, might as well. And we will use a bit of heat shrink as well while we're here. Put it on these wires. Man, we're getting very close to being done all the hardware on this project. I do have to do some more tweaks on the rails because they're not sliding perfectly. The linear slides. I think what happens is when I like mount them on there, when I bolt them down, they kind of twist a little bit, so it adds a bit of torque and it doesn't want to slide perfectly. So I just have to, like, once it's mounted, then like kind of twist it a little bit to release that tension. And hopefully it'll be good to go after that. It'll take a bit of time, I think, to find how I need to tweak it. So that may not happen tonight. We'll see. I might just get done all the hardware and say, you know what, and do a bit more software testing, and then be like, we'll have to wait till next time. I also have to figure out how we're gonna make these guys autonomous. If you have any ideas on how these 2 should detect each other, we're at a point that maybe we'll use USB cams because we have no more ports on the Arduino, and I guess we could possibly wirelessly connect. Since we're using a serial connection to the computer, we could wirelessly connect maybe a couple IoTinies, make like some sort of IoTiny backpack to go on the back of these guys with cameras on them. Maybe. I've never used two camera controls simultaneously, so I don't know how that works. I don't know if it'll actually work. But I think like cameras is probably the way to go to detect each other. One will just have to detect blue, the other one will detect red. If it gets in its hitbox, it'll box. For the rest of the time, we can probably do like random values for like kind of searching. So its base will move around. It'll search until it finds the other robot, hit its hitbox, and then it'll start punching. What I mean by hitbox is like it'll find, we'll make a square, or like, yeah, I think we'll change those. I think you know how we have the bars, those red bars in an Easy Builder on the camera control. So we'll squeeze those red bars in and make just like a small space where it needs to detect blue or red, and then once it does see that, then it'll punch. And then we can also, just have one with a camera on it, and the other one will be controlled by myself or somebody else. I really want to use the Power Glove to be able to just like, bow, 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 do some boxing, some real life boxing, and then see like, the blue bomber throw some punches, and when I throw a punch, it'd be probably, oh, thanks, Martha. My wife is on the stream, guys. Say hi. Yeah, I think that it's going to be a lot of fun using the Power Glove for, like a real life boxing game. I think you could use it in Mike Tyson's Punch Out originally on the NES, but it wasn't like a punch. I think it was like you actually had to like squeeze or something to actually do punches. It was something weird like that. So it'd be awesome to be able to like actually throw your fist forward with the accelerometer and it get picked up as an action of a punch with, like I said, the blue bomber or the red rocker. I think that'd be awesome. That'd be one of the coolest feelings. And then, yeah, battling your friends as well. I wish I had a second Power Glove. That'd be the best. But sadly I don't. But that hack took long enough. If I were to replicate it, I guess I could do it with just like flex sensors and an accelerometer and that kind of thing. That would definitely work. I think it'd be much easier just to make my own glove, just like ghetto glove, and we could do that. Maybe I'll devote another hack session into making a ghetto Power Glove. It's not as fun as the real thing though, because having that kind of power in your hand is amazing. It's so bad. Let's just say that. So back to the Switch. Let's start doing some more soldering on this thing. I guess I could turn up the music a little bit. This song's actually pretty decent for copyright-free music. So it's called "Why We Lose" by Cartoon. Actually, I really like Cartoon. They have another song called "On and On" that's pretty good. Probably the best copyright-free song you'll get out there. Yeah, if you have a spare moment, definitely check out Cartoon "On and On." You'll find it on YouTube or pretty much anywhere. Oh, welcome by the way, Martha. Sorry. Great to see you on here. I hope you're having a good night and the kids went to bed easy. guys. I'm trying to think. I think this is episode 28, I believe, of Lab Hacks. I've been doing this for 28 weeks, not in a row, but that's it's quite a few weeks, and we're almost, yeah, 52 weeks in a year, so we're about the equivalent of 6 months in, but I'm sure it's been longer than that in terms of real weeks. Alright, so we soldered those connections, just need to melt the heat shrink on them. Test if it's all good. And then we'll drill a hole in this guy here and we'll hot glue this switch onto there. And this will be our kill switch, or e-stop switch. Using some hot air here to shrink this heat shrink down. Okay, let's do a little quick test on this. Should be open. Infinite ohms. Okay, and now it should be closed. There we go. Cool. Good to go. Alright, let's find a drill, some drill bits, and let's do some mods here. Hacks upon hacks. Hole doesn't have to be that big, just enough for these wires to pass through. You know what, I think I'll chop off the rest of these pins. Don't really need them. I think they'll get in the way when I'm putting this thing through. Okay, I think this drill bit should be wide enough, but it will measure. Yeah, that's even a little bit too wide, so let's go a little smaller. Yeah, that's fine. That's good. If you want to see what I'm doing over here, I'll transition. Just give me a quick second here. There we go. Okay. So with this being like so, we'll probably want our limit switch around this area. We don't want to get too close to this guy, because this is where the ring goes. We can actually put the ring back on today, but I think it's just a little bit easier with, you know what? The ring might help us actually. When we tip it over, it won't be leaning on the robot so much. So let's put the ring on. This is what it'll look like when it's done actually with the ring on there. So today all the hardware goes back together. Even the ring. So tangled up. guess I can turn this down a little bit. There we go. Okay, it's all tangled except for untangled except for this one. Oh, here we go. I think I got it. Pull these through here and we should be good. Okay, those two are good. This guy seems like it's twisted. Okay. They should snap into place like so. Good, good.
Some call it heat. Some call it good taste. You know what to listen to. So why are you listening to music you don't? Try Premium on unlimited steps.
Alright, well, it's got a bit of tension on it.
Turn up the ones that make
That's the way
party.
it's supposed to be.
Picky folks like you love Premium. Tap the banner now to find out more.
Oh. Oh yeah, I forgot. But yes, it's working. The ring is holding this whole thing up. Beauty. While we're here, let's do a bit of hot glue. Oh yeah, gotta rough up the plastic first. There's always missing steps. Yeah, this plastic is definitely doesn't allow hot glue to adhere to it very well unless we scuff it up a bunch. There we go. Excellent. Alright, let's pour on the hot glue. And let's hold that there for a few moments. It's almost time to put the shield back on. We gotta drill a hole for that switch. Maybe we should line it up to make it kind of symmetrical like this. So let me grab a ruler for a second. Okay, I'll mark that with the dental pick. Try to find the center here. It's 1.8. So 9. There we go. We got our center marked. Alright, hopefully this is not too loud on your speakers. Switch is drilled. Okay, it's one pin pin at a time. There we go. So we'll hot glue that guy on there. I forgot that the switch is kind of a little bit offset because of where the pins are. So what I can do is bend the pins down a little bit. Should center the switch a little better. There we go. So stick a little hot glue in the center of that hole and then pull it down. And then hot glue around the body. This is actually the only thing that's hot glued on the outside. Yeah, I wonder if that wasn't that great of an idea, if I should have just had the switch popping out from the other side. But it's definitely the functionality versus the look of it. Fashion over function. And this time function is winning because I don't want to have to push a switch, or when I push it, it like falling on the inside of this thing. So I definitely wanted to have it be a solid push button on the outside here, and it not slip or anything. So the way we have it now, it is going to be super solid. Wait for that to cool. I think that's good. Get some of the stuff out of the way. We don't need it. Oh wow! I didn't even know there was a large version of Rock'em Sock'em. That's sweet. We'll have to be on the lookout for that. Yeah, this version is definitely a bit tight. I had to make some concessions on the height because it was difficult to fit all these guys, all the linear rail systems in there. So the height is increased by like 2 millimeters, like an eighth of an inch, I guess, maybe. Just by the height of a pad, basically, is how high to bring it up. Just to have clearance for all the screws and stuff that are coming down. You know what? Come to think of it, I think I only added the pads because the limit switches were sticking out. And since I changed limit switches, we actually may be able to drop this all down by a little bit. But you know what? I like it how it is. Don't change what you don't need to, I guess. Okay, perfect. We have our switches working up here. I'll give you guys a close-up of it. It's our kill switch. It doesn't look all that pretty, but it'll work good. Like I said, it could have sunk it down into the body, but then if you press on it, it might, fall in. That's the only fear. So it's nice that it's going to be a solid connection here. Yeah, our board is nice. Our other power supply board is now solid in there. It's now hot glued and good to go. So time to put this back together. Put the shield back on the Arduino. Make sure we have all the pins lined up properly. Perfect. And we gotta put these wires back in and the barrel jack back in as well. Okay, now where do I put my screwdriver? Oh, there it is. Don't need this. So after we connect these all up, that might be it for the hardware. Happy days. It only took 7 hack sessions to finish the hardware. Well, actually I lied. The hardware is not actually finished yet because I still need to make a little camera thing. And what I mean by camera thing is a little camera backpack for each robot if we go that way, for them to detect each other. I think color detection is going to be the easiest. Sorry if I'm in the way there, my big head. Alright, solid. See how our connector lines up here. Not perfect, but we should be able to adjust it. There's a little bit of hot glue left on the inside of this for some reason, so let's get that out of there. Oh yes, we are also diffusing today. We have our trusty diffuser, and we're diffusing Young Living's Pan Away, which is very awesome smelling. I heard from a friend of ours that if you put Pan Away and Stress Away together, it's supposed to smell like root beer. But I haven't got the combination right yet, so it doesn't smell like root beer yet. It's probably there's probably a ratio, but I don't know it. I heard you can find out different combinations on Pinterest, I believe, is the popular place for that kind of thing. Okay, so let's get this connector in a place where it can connect a little better. Okay, that's good. Hot glue it in that position. Oh, yeah, probably a better idea to go like this. We'll throw some hot glue down here on the board as well, on the back of this switch as well. Let that cool down, and then we'll start connecting all these connections back up. And then it's off to doing some more testing and some coding and some adjusting. And we'll see if we can get all the servos working. It's going to be exciting. All these spider webs. yeah, if you're just joining us, we are hacking the Rock'em Sock'em robot game to be autonomous. We actually had to build two sections, two robots, basically, essentially, and they're going to be controlled with the same controller here. This controller actually does everything. So it controls stepper motors that are these little, they're a hacked CD DVD drive linear rail system. So one of them, I think this is just like, yeah, this is for, you know, your upright computer CD DVD drive. Now we have laptop CD DVD drives for this direction, so that the robots can move in the X and Y directions. And why I'm going like this and not like because we have it set up that they kind of move a little bit diagonally, because that's the way the plastic is, the boundary of the plastic is underneath here. So there's a physical range that it can go in, which is like closest is like front on here, furthest is over about here, and then it can go in this corner and this corner as well. So it doesn't move that far. I think probably like at least maybe 1.5 inches in each direction. But yeah, you'll see that once we start making this thing go. And yeah, it's connected from this Arduino. It's got custom firmware on it that DJ Schur's created that allows us to connect this to Easy Builder. So we're using an Arduino as an EasyB. So kind of a new function that we added this year, and it's pretty awesome to be able to do that. So not only is the Arduino controlling those steppers, it's controlling some servo motors that are under here, and those servo motors are used to punch the fists. It presses a little pad that has I guess a lever system, a spring and lever system that goes up the leg of the robot and makes the arms punch like so. And I'll show you that in a few minutes here after I connect everything back up. So I think all the hot glue is good, so I'll cool off. So now it's time. It's a bit annoying down here just because everything's pretty tight, but fits in okay. This Arduino shield, oh actually the Arduino plus the shield plus the 4 drivers was actually a very surprising price. I didn't expect it to be so cheap. You can actually find it on Amazon for $29 Canadian, I believe, which I don't know, that's probably like $10 American, I'm guessing. But it's very inexpensive, and I'm surprised that it has all the features that I wanted. It can drive 4 stepper motors and still take in inputs from, we have a couple of sensors on the robots to tell if their head popped up or not. And it also can drive. It has enough room to drive servos and take in inputs from limit switches. So we have limit switches on the homing axis, I guess, for each of these. I should say not the homing axis. I should say like it's for homing the axis for making it go all the way to its start position, and allows it to kind of recalibrate and see where it is in software. We don't have any encoders, so that's why we're using limit switches. Otherwise, you could tell how many turns the stepper motor took, but we don't have nearly enough input-output pins to do encoders or anything like that. So we're just using simple limit switches connected up 2 motors. Let's connect up the other 2. Alright, we're good there. Let's take our new switch, connect that up. Looks like I got a little bit of hot glue on these pins. Unfortunate. There we go. This little switch that we added in is our motor enable for all the stepper motors. I guess I didn't mention that all the motors that you get from CD drives, I wouldn't say all, but most of them are stepper motors, which need a little bit of a different system to drive them. Normal motors are like you send them an on and an off to go one direction, and then an off and an on to go the other direction with your signals. With a stepper motor, you got to drive the cogging effect is what they call it, I guess. You drive 2 coils, and the coils create a magnetic field to make the motor cog. So you have to energize them in a certain sequence to get it to turn one way, and then the opposite sequence to get it to turn the other way. So steppers are a little different. So you need 4 wires to go to a stepper because you have 2 coils. A coil will have 2 connections on it. And they also need a higher voltage, which is interesting. Most DC motors are fine with like 5 to 12 volts. With stepper motors, you usually need, well, these ones could be okay with 5 possibly, I'm thinking, but usually you need 12 to 24 volts to drive a stepper motor. Alright, enough of me talking, let's get to connecting these things. I guess I could grab a couple bins, make this a little easier on myself. And maybe you guys can see a little better as well if I do this. Yeah, if anyone's fashion and function. That's not possible, Martha. You can't have fashion and function. If you do, then you know you've got a hit on your hands, I guess. Yeah, I was just saying, if you're newly watching and you're wondering what's going on, definitely jump in the chat and ask some questions. I never thought of it, but I guess I could hot glue these together. The servo wires can there. I think I'll do that later. Yeah, these white and black wires, those are our servo motors that are, like I said, the punching action. Some of them are limit switches as well, like these ones here. So this one goes to SCL and ground. So these two servos we will connect to X and Y, and the other two Z and pin 8. So X and Y. This guy will be Z. And this guy will be pin 8. This guy goes to SDA. Okay. Oh yeah. We have our two head sensors which go to abort and hold. And then we should have two more limit switches. One goes to resume. And where's the last one? Got that one, that one, that one. That's 3 limit switches. Where's our last limit switch? Should be black and white wire. Okay, no, it's not. I think it's yellow. No, there it is. Green and blue. And it goes to cool. Cool enable. Okay. We've got so many wires here. I think we're going to have to get a twist tie. Twist tie them all down so we're not interfering with any movement. Oh, I forgot a ground here. I wonder if I got flagged for this song. It's a cover of Where Is the Love, so I wonder if it's different enough though, if I won't get YouTube copyright flagged. Okay, all our wires are connected. Let's clean this up a tiny bit. And it's time to do some testing. What are we at for time? Oh, right, we have about half an hour left. That's awesome. Okay, let's twist tie this up. We don't need that much twist tie, so we'll cut it in half. I was explaining before, when I mount these guys, it seems to twist the gantry a little bit, so it doesn't actually move as well. So I will have to do some fine adjustments. Oh yeah, this one has a hard time moving. I think I'll try to get this wiring kind of attached up here. Stick one twist tie through another. There we go. So that way we can hook it onto here and mount it on there. So we don't want the wiring to be hanging out down to the bottom because that's where our movement, stepper motor movement, is sliding around. Go. Also got to make sure that things can slide around with enough slack on the wires. Definitely having a hard time moving that direction. Could be that they're catching on each other underneath as well, but looks decent enough. I could add a bit of hot glue onto some of these connections to make sure they don't come apart, but it's fine for now. Put this under here. Okay, I think it's time to test this out. All right, so this is how it's going to look. Besides possibly the bottom socket robots having backpacks on them with cameras, we'll see. Okay, so we'll connect up to here with power. Actually, I didn't test this connection yet. Good, works. USB. This is our communication to the Arduino EZB. Let's switch our view here. There we go. We have Easy Builder. So let's connect up here. We are connected. All right, let's test this, our D8 pin. Oh wait, our D8 pin is now a servo pin, I forgot. So We can start our script and see if anything moves. Nope. We can adjust our script because we don't need to set D8 anymore. D8 is not. Oh, there we go. D8 is no longer our enable pin. It is. Oops. It is now a servo pin. So I'm going to get rid of that. Save that. Start. Nothing happens. Okay, now we put the enable on. There we go. You can hear one of the axes is trying. Yeah, things are gonna have to be adjusted, but that works. And I will disable the steppers by just unclicking that. Let's see if the limit switches are all working. So some of them, yeah, okay, ADC 5 goes to 0. Perfect. Let's try the other limit switch. I'll need a screwdriver for that one. There we go. ADC 2 just went down to 0. Let's try this limit switch here. ADC 3 went to 0. And the last limit switch should be ADC 4. Yeah, down to 0. Okay, so I'm going to throw some numbers on these so I remember which is which. Actually, I'll just use this. So this should be 4 or 3? I don't remember. 4. So this is 4. This one should be 3. Yeah. This one is 5. And this one is 2. Okay, there we go. Limit switches are tested. Now we gotta see if our head sensors are good. They'll be ADC 1 and 0. We'll change values. So that's ADC 1. You can see that goes to 2 volts. I bring it down. That goes to 2.6. Let's try this one. 2.4 goes down to 1.7. Excellent. Sensors are working. Now it's servo time. So we have, if I look at we have pins. Digital 8, 9, 10, and 11 will be our servos. So let's go back to Easy Builder here. So right now we have this one, which is set up for 10. I think this one is 9. Yep. So we need a 8 and 11. So we'll add project, add servo, horizontal servo. We'll go minimum 1. Oops. Max 180. And we'll do port 8. Save. Alright. Yes. Right on. I guess you guys can't. Oh yeah, you can see that in a little tiny picture above my shoulder. You can see that working. Okay, good. And then the rest of that one will be 58. One more. Horizontal servo, and this one will be D11. Okay, there we go. So it looks like that servo is running into something. We will have to investigate. But it's working. Yeah. definitely running into something. And this one, that one is working. And this fist, that left hook is working. Okay. Everything is working except we haven't tested the other stepper motors. And so what we're going to do is we'll copy and paste this script. We'll make 4 different scripts, one for each stepper motor. Copy and paste that. So we'll just call this, I think it's going to be red y-axis. Well, I'm just going to randomly label these right now. We'll make them the proper ones once we have everything figured out. Easy script. Go to easy script, copy and paste this. Red x-axis. So let's look at our diagram for a quick second here. There is D12 and D13, but I don't know which is which. So usually the lower number is the step, and the higher number is the direction. So if you didn't see this earlier, sorry, we did a bit of coding earlier, and we figured out what pins that we needed to send what signal to. This is Arduino code that was ported over to Easy Builder. It's very rough. So, okay, I'll enable the steppers with the button. Yes, I can hear something moving. I think it's on the blue axis actually. Yeah. So I'll just change that to blue. So good, I guess we got the direction and step pins correct, so that's good. Okay, 2 more scripts for so let's call this the blue y-axis. Sorry, it's just kind of off screen at the moment. There we go. And let's just have a quick look at our diagram. So, actually let's not look at the diagram. Let's look at the code, the Arduino code. And it'll tell us what pins are what. So we have X was 2 and 5. Y will be 3 and 6. Okay, let's do that. So 3, 6. Okay, save that. Yeah, that's definitely on the blue. Perfect. Okay, and then we have one more to do. Sorry, this is off screen again. There we go. Let's look at the code. And the last one is Z, which is 4 and 7. change this to red. Is it Y or X-axis? Save that. All right, that's working as well. Not working perfectly because we don't see much movement right now happening, but we can hear it at least. I'm gonna turn the steppers off because otherwise they're gonna heat up. Sorry, I have a bit of excess hot glue here. Just want to take that off. Oh, there we go. Okay. Sorry, just a bit of the aesthetic gets lost when there's just a bunch of hot glue sticking around. Okay, so all the functionality is there. Hardware is complete except for the camera portion. We have all of our scripts done. So when we need to, these are just test scripts, so we will need to adjust them where if we hook up a controller, we press up, it'll actually go in the right direction. So I think we're getting close to 10 here. I don't think I'm going to put the time into getting that all figured out. I will have to, on my own time, tweak up these linear rails so that everything's sliding nicely, because right now it's shenanigans at the moment. We'll save this, can't forget to do that. We'll figure out some of our servo values, also some of the servo movements. We saw, I think, 2 of the arms that are having trouble punching, so we'll have to tweak that up a little bit. Maybe we'll even add some 3-in-1 oil, classic, or as DJ calls it, 4-in-1. I don't know what that fourth, I don't even know what all the 3 functions are. It's oil, okay? Why does it have to be called 3-in-1? I don't understand. I'll have to read the label. You know what, let's just do it. I got a few minutes here, let's just, why is 3-in-1 oil called 3-in-1 oil? Riddle me that. Oh yeah, we could, I wish we could add LEDs, but we can't control them because we have no input-output pins left, unfortunately. We could just put some bling LEDs on there though if we wanted to. Okay. 3-in-1 oil. This is the stuff. This is an awesome lubricator for all kinds of stuff. Why is it called 3-in-1? Okay, here we go. This is why. Because its formulation is ideal for lubricating the moving parts of electrical motors. Well, I guess it's not flammable. Pneumatic tools, lawn tools, and much more. Well, that doesn't explain it. I thought it was just 3 applications, but that's more than 3-in-1 motor oil. Created a special blend of high-grade oils that is equivalent to SAE 20. Engineered for 1/4 horsepower motors or larger. Long-lasting. The mystery. Oh, guess what? It's created by the WD-40 company, which is interesting. People usually use WD-40 for lubricant, but that's actually not what it's meant for. WD-40 doesn't really last. It's supposed to, WD-40, I forget what they call it, it's hydrophobic, I believe it's called. It actually takes moisture out of whatever you're spraying it into. Sorry. And that's its application. It's not actually supposed to lubricate anything. But this is a lubricator, and the mystery is still not solved. Why is it called 3-in-1? I guess we'll never know. Maybe next week. Maybe next week we'll answer that question. Do some searching, see if you can find the answer. I'll do my best. But I don't think it's just the 3 applications that they list on here, because it says and much more, so maybe much more is the 4-in-1. Maybe it actually should be called 4-in-1. Who knows? A mystery that needs solving. Alright, I think that's going to be it for me tonight. Thanks for joining me. It's been great to have you guys. Thanks for jumping in the chat. Appreciate you guys keeping my spirits high. And yeah, we're almost there, guys. And girls, if Martha, if you're still there. We're almost to the end of this. We are so close. We do need to do a bit of programming. But we have the hardware there, and I need to do, obviously, some hardware tweaks, as I mentioned before, to make sure things are sliding smoothly, because it's not perfect right now. But until next time, have a great weekend, everyone, and yeah, we'll hope to see you next week. Thanks again. See ya.